Evening all. My name's Antony Patchett. I'm a test engineer at SessionCam. The meetup blurb said I was working at Flagship. That changed about 6 months ago, so mostly up to date on that side of things. I did tell Paul, but I'm guessing that wasn't his highest priority to change the page.
I got lost in one of Scott's threads, so...
Yeah, that's fair enough. Okay, so I'm going to talk about software testing in Agile. Before I start, are there any other testers in the room?
You don't take we're all testers.
Yes, you're all testers. Everybody's a tester. That's how it works. Yes, honest gov. So, what I'm going to be covering, talk about the purpose of the talk, and then talk about some test analysis techniques, some of the challenges in Agile and Scrum, not just Scrum, in terms of software testing, and then I'm going to spend a chunk of time talking about exploratory testing, which is an area I think gets often overlooked or poo-pooed on by a lot of the testers around the place, but I think it's a very useful tool, and then we have questions at the end. So, it's not explained to experienced testers, which is good because there's none in the room. The primary aim of this is a mixture of, for beginner testers, but also something I've discovered along the way is, well, if you didn't already know, testers and developers have very different mindsets about how we go about things. And one of the things I've been trying to do is improve the understanding amongst developers about the tester mindset, not just so we don't seem like we're horrible people that break all your code all the time, but also because it can be useful in your own work to understand how we're thinking, because we're always looking for why things will break and where the problems are. And if you think of those ahead of time, then when it gets to the testers, you've already solved the problems. So, you might have heard this before. A tester walks into a bar, orders a beer, orders no beers, orders 3 beers, gives 4 back, orders -1 beers, orders 3.15 beers, orders a goat. There's an element of truth in this. There's various different versions of this, but behind the scenes, there is a reason why that sort of thing seems to go on when we take on a piece of your work. So, I don't know if you've heard of this before or not, but there's Blackbox testing versus Whitebox testing. So Whitebox involves knowledge of the code. You can tell what's going on in there. It's usually you guys that does this, whether it be dev reviews, walkthroughs, unit tests and so forth. You build the test and you do the testing knowing how it's all been built and how it's supposed to work. Then you've got Blackbox testing, which is where a lot of us testers sit, and that can be summed up as input, magic happens. And then something comes out at the end, was it what we expected? We don't know anything about what happens under the hood, and for a lot of this sort of testing, we don't want to know either, in the nicest possible way, because if you start knowing about what's going on, you'll start to adjust your testing to test what you expect to be happening and how it works. If you know nothing about how it works, all you're then looking at is, did I get what I expected when I put that in at the front end? Because from a customer's point of view, that's what they care about. They have no care at all about how amazing your code is. What they care about is, when they press the button at the front end, do they get the answer at the end? So, why test analysis? Well, the obvious thing is to try and get the maximum coverage of what we've built for the minimum effort. It's very easy to sit there and write 11 billion test cases and look at every single aspect of every single thing that you've built, but actually, is that really getting you the most bang for your buck? And so test analysis gives you a chance to work out where is the most efficient way to work. And the other cool thing about this is to give that maximum confidence of quality. At the end of the day, nothing ever goes out 100% guaranteed bug-free. You can't make it happen. All you can do is give an indication of how sure you are that there won't be anything that the users will find before we find it and fix it in the next release. And so that's the idea of test analysis, is not only can I turn around and say, I've tested loads of stuff, I've done great things. I can say, I've looked at this, this is why I've tested what I've tested, these are the results, honest gov, you can believe me. So, talking about some of the test analysis techniques, one of the most basic ones that we use is something called equivalence partitioning. And the principle of this, easily explained by this example, is you've got a requirement. Values from 0 to 100 are valid. So what equivalence partitioning presumes is every value within a given partition is as good as any other value. So you've got 3 partitions. You've got less than 0, you've got 0 to 100, and you've got greater than 100. So if you're going to be tested, there's no point testing what happens if I put 0 in, 1 in, 2 in, 3 in, ad infinitum. If it's correct that they are, any value between 0 and 100 is equally valid, then 2 is as good as 75 is as good as 13, because they're all the same partition.
Isn't 0 like an edge case that you take before, like sometimes?
Well, that's why I've written it the way I have, values from 0 to 100. If it said slightly differently, that's where it starts to come in around whether that's an edge case or not. And when I wrote this out first time, I went, someone's going to pick that up. I'm going to change the wording of that very carefully to cover that off. But you do bring on to the next technique, which is boundary value analysis.
So in edge case, if it's a unusual, not if it's just at the edge of what you're testing.
I'm just thinking in code, like we have to maybe treat empty collections differently to, well, if you only test it with if you only test it with zeros, if you're saying 0 to 100 is the same, and you only test it with 0, then you've only tested it with an empty collection. So
Well, in this situation, we are talking about values. We're talking about integers or something similar, the value of 0 to 100. When you're talking about, in this instance, you'd actually start arguing, well, in that case, what you're looking at there is is there a difference between 0 and null, for example, and that's a slightly different thing to look at. In this instance here, what you're basically saying is if you basically got an area that you say is true and anything outside of that area is false, which should mean anything within that true section is equally valid as any other. So therefore, one test case, I'm going to pick a random number between 0 and 100. That is my test case for that whole partition. I choose any number less than 0 and any number greater than 100. I've now got 3 test cases, rather than theoretically an infinite number all the way across the board, at the very least 100 for that main true section. So we have boundary value analysis, and we're using the same example again, but what this is now focusing on, is nearly what you're talking about, is the boundaries. So these aren't really edge cases, but they are sort of, the boundaries areas. So if you've got 0 to 100, on one end you've got -1, 0 and 1. So 0 is our boundary point, so we'll test that, and 1 value either side. In this example, we're talking whole numbers rather than any decimals involved. And likewise at the other end, 99, 100 and 101. Now this is more powerful than equivalence partitioning for 2 reasons. One, you include equivalence partitioning in this testing, because if you look at this, 1 and 99 are both in that 0 to 100 partition. So you're doing that bit of work anyway. But more importantly, you've now got six test cases here, which are all looking at the most dangerous areas when it comes to faults, which are the edges. Talk about edge cases, but whenever you have a boundary between one thing and another, from our point of view as a tester, that's the most likely place where there's going to be a little bit of misunderstanding or something like that going on. Then we've got transition state testing. Now this, I'm giving an example here, which is basically your classic example of putting your pin into an ATM. So you can see on here, you start off, you get your first try, get it right, yeah, you can find out how much money you don't have. Get it wrong, you've got to try again. Same again, but on the third try, if you get it wrong, you get locked out. And this is a very simple process on here, but on the other hand, this could be quite a large process if it was a large piece of software. The idea of this, though, is if we map out what are all the states you can be in and how do you transition between them, we can then make sure we get coverage of ensuring that you can follow all the valid paths and you know what the invalid ones are. So it shouldn't be possible for me to go from my first try to account locked. If I can do that, that's an invalid state transition, and that means I found a fault. On the other hand, once you've got to account blocked, you shouldn't be able to get out of it back to your start again, because that's an end point there, and if you can somehow magically get back and put in a fourth try, again we have a problem. But by mapping all these out, you can then look at it and say, right, okay, I've looked at every single route through here. It also tells you straight away that you could go through the real hassle of putting in your pin twice to test out that last one, or from a testing point of view, you can set up your test case to start from, I've tried 2 times, I now need to look at my third try. Transition state testing tends to work best where you have sequential activities going on. So you go from A to B to C and you need to follow a particular order. You can't go from A to C, you've got to go A, B, C. Decision tables tend to be more useful when you're looking where you've got independent rules. You can take any particular route through this and you'll get to the same place. So the example I've got here is a username and password prompt, that common thing we always see. And the principle we've got here is we've got 3 conditions. Username, true or false, correct or not. The password, correct or not. And output, did you get in, did you not. So when we start to map that out, we can see that we have a first rule, which is if you put in the false information or incorrect information in the 2 fields, you don't get in. 2 rules there, 2 and 3, where if you only get one of the 2 correct, then you don't get in. And finally, get it all right, yay, you've got into your computer. Now looking at this, you could say, without doing this analysis, well, you've got to do 4 tests. You've got to find out what happens if you put 2 things in wrong. You've got to find out what happens if you put, if you follow rule 2 and put the right password and right username and wrong password, so and so forth. So that's 4 tests. While we're looking at this, you can actually see you only need 2 test cases. You can say straight away, either I put them both incorrect and I get in, or in the example of this username and password prompt, if I put anything in that's wrong, I don't get in. And straight away, you're now down to 2 test cases, which will test the functionality of that login. Because on a standard username and password, you're not looking at going across what are you going to say?
Sorry, I was just going to say, maybe in more complex or situational things, I've been wrong here, but surely the case there of any combination of incorrect input infers more than one case wrapped into one there. So you've made one logical case out of many practical implementations.
Okay, well, it might just be wording on that side of things, but what we're basically saying is that Rule 1, Rule 2 and Rule 3 in these 3 examples are all equally valid. It doesn't matter which one you choose, and you only need to test one of those 3. In terms of how do you know the username is valid, that's not relevant for this. What you're looking at is when you put in the value, if the system says it's good, then it's fine for this. If the system says it isn't, for whatever reason that is, wrong spelling, not actually an active user, been locked out because you've been sacked, whatever it might be, it doesn't care. That's not what we're looking at. We're looking at straight up that prompt. If the computer says yes, that's okay. If the computer says no, it's not. You need the computer to say yes on 2 fields to get in. If it says no for any reason, you don't get in. The reason why doesn't matter for this, so it's either one false or both false.
So if you've got a bug where a username is allowing any password and you don't test both scenarios, then you've missed a bug.
You could do that sort of things, but on that there, so you've got a case where in that situation you'd be putting in a true username and a false password, in effect, and you still get in. But you'd know you're putting in a false password in because you're setting your data. So you're not on that sort of thing. So when you're setting your data up, you'll have a set name of usernames and what their passwords are.
So are we now into the Whitebox testing?
Yeah.
No, you're still on Blackbox because you don't need to know how it works it out. Your test data you set up, you can say, right, I'm going to have 2 usernames.
So considering the test data you're input into the Blackbox?
Yeah, you're setting your input up in the first place, and you're saying, this is my user list, and these are their passwords.
If you know what the password is,
Yeah.
you still don't know that it's failing but it's succeeding for the right reasons, do you?
On that sort of thing, so if you know that you're putting in, so on that side of things, if you know what your if you've got the case, so you've got John Smith, their password is password 1, sort of thing. If you know that's what you should put in there, if you put in John Smith and you put in Bob for the password and you get in, well then you know you've not put the right password in, that should be a false, and that therefore you know you found a fault on that side of things, because you know what information you should be putting in and you know what your results you should get are. And in all these cases, if you don't get the result you expect, then you've possibly found a fault. Or you've done it wrong, that's the other option. So that's where this comes from, and it is about trying to reduce how many you have, because if you know what your known inputs are, I'd say the black box part is, if I was doing this, I don't care what authentication you're using, I don't care how you've worked it out, all that matters is if the database says, a Patchett with password 1 should let me in, however the magic in between happens, if I don't put both those in correctly, we have a problem. And that's all from the black box testing point of view, that's all I care about.
So are you doing this stuff by hand?
I'll come on to automated in a minute on that side of things. And in fact, that does actually tie on. One quick thing I will mention though are the illities, which I'm not going to go into a great deal of detail. So you've got scalability, usability, portability, maintainability. As I say, security. They always include security in there in the illities. These I'm not going to go into a great deal about. I can talk about outside of this, but these all require particular methods of looking at, usually special test harnesses, extra bits of software, and other ways of approaching it. And that's a good set of 6 additional talks. No, I'm not volunteering. Other talks to talk about.
I was thinking a one-day workshop, actually.
It could do on that sort of things. Unfortunately, for some of these things, the only way you can meaningfully do it is if you're prepared to pay a large amount of money for the bits of software, or you use something that's basically hand-cranked and not worth the effort. On there. So I want to mention them because there's an area that they're often called non-functional testing, which I don't personally like because it's still actually the functions of the software, but it's usually given that name. So, as I say, automation coming up, challenges of Agile and Scrum. Now, you've seen all that talk about test analysis. That's just 4 or 5 of the techniques. There's a whole box of other techniques of test analysis around the place. The problem is, you don't exactly have a huge amount of time when you're working in Agile and Scrum. So you've got the situation where you say, right, we're going to do our sprint planning, or this is what we've got on our Kanban board, however you work it. This is the next item we're picking up. We've decided today we're starting this afternoon. As a tester, you're going to go, when am I going to do my analysis to work out what I need to test on this? because in the great old days of waterfall, you'd have plenty of time to do all this analysis before the developer even got to know what they're supposed to be coding. With Agile, of course, you don't have that. Some of the time you have the situation where, I've had the situation before now where I've said, right, okay, what's the next thing I'm picking up? And someone's gone, I finished this work item, you ready to test it? I'm like, I didn't even know it was going to be tested just yet, and you've finished it because I was looking at something else. So there's a severe time pressure on working anything out. There is no lead time in real terms. Particularly as, in terms of your requirement changes and clarity, it's that last minute. So I could see the backlog and see the 5th item down in the backlog, whatever it might be. That's what it is. I'm going to do a load of test analysis ready. Oh, good news. We're not doing that anymore. We've binned it off. Or we've had another workshop and we've realised we're completely changing what the requirements are. And you're like, well, in that case, I've blown 2 days of analysis on something we're not touching anymore. You just can't do it too far ahead of time.
For us as developers.
Oh, completely. I'm not saying it isn't, but all of that analysis ahead of time literally isn't possible in Agile and Scrum.
I'd also argue that as developers we come to the stories or whatever in the iteration fairly blind.
Oh no, Oh no, I'm not saying it isn't at all in any way, shape or form. I'm just saying, what I'm more saying is, all that talk about analysis, and in the best world ever for a tester would be to say, right, here are the requirements, they're not changing. I've got plenty. I know we're starting it next week. I can analyse that and be ready to go as soon as you build something. Probably the same for a developer and that side of things, having a pretty good idea, but from a testing point of view, we don't have that. On top of that, there's conflicts. So if you're working in Scrum, you've got the situation where in this sprint, I've got 4 new work items to test. Oh, and we're releasing last sprint's work because that's ready to go. So could you regression test that too? Oh, and you need to analyse what you're going to be testing so you know what you're going to be testing it right when they finish developing it. Good news, it's all happening in a 2-week period. It's just not possible. It's so difficult to balance that out. So you're taking stuff on, while you guys are building it, you can try and get some analysis done, but probably you're doing the regression testing for the next release. So as soon as you've got that out the door, then you've got the situation where you're going, okay, marvellous, now you're ready to test now, but I haven't had a chance to analyse it yet. And the next thing you know, you're in the last 2 or 3 days of the sprint, and the tester's frantically trying to test everything, and hopefully they won't find any faults, because if they do, then that means that work item isn't done that sprint. And it's a constant cycle. And I'm not saying we've got a terrible, we've got a terrible life compared to developers, but it is a clear example of the conflict of time and resources that testers have to deal with in this scenario.
Doesn't that just mean that Scrum is the wrong approach? Oh, my good piece of code and the correct tests to prove that it was worth doing and that we've done it right did not fit into this arbitrary business requirement of some magical 2 weeks.
Potentially, but well, it depends. Well, looking at another way, then, even if you don't have that and you're working in a free-flowing Kanban or similar situation, you still have that similar sort of problem where all of a sudden, because you're doing the regression testing or the bit of analysis, you've now got in the column that says ready for test, there's 72 items, and you guys are saying, well, hang on a minute, we can't, if there's a limit on that column, whatever it is, why aren't these things getting through test? It's like, well, I'm actually checking that bug fix and getting ready for the next release, and I need to look at what the hell I'm testing on this. You still have that. It's a similar sort of problem on that. There's a general conflict of time. However you look at it.
Sorry, the Kanban, you just screw.
Yeah. Whichever way you work on that side of things, you're going to have that same problem. And that's one of the things that comes out in Agile and Scrum compared to Waterfall, and I'm so happy I don't work in Waterfall, I'm not even saying that. But in an Agile, Scrum, that sort of environment, whichever flavour you prefer, there is this constant situation where you don't have a nice, good lead time as a tester, and you've got those conflicts going on.
It's even worse when you don't add in UX and design work going before developers even get there.
It all ties in again, because from a testing point of view, I can't, if I'm picking up an item, I can't do proper analysis of a work item until we've finalised what the requirements are, so I know what I'm supposed to be testing against. Testing is, you put this in, you should get this result. If we don't know what that should is, you can't work out how you're going to prove that when you put that input in, you're going to get that answer. So that is the major situation, the problem with that, where you don't know until that point in time. It may also be the case that you guys don't even know how the hell you're going to do it till you pick it up, which actually, from my point of view, and the black box testing, is perfectly fine, because I don't care how you're going to do it. But I need to know that if you put in 1 + 1 at the front, you should get 2 at the end. And until we've pinned that down, I can't start doing proper test analysis.
So that should be pinned down in the user story workshop.
Yeah.
And it should be pinned down in the pre-sprint planning.
Yeah.
You know exactly what
Yeah.
So you're happy path,
Yeah.
how
Yeah.
you're building a product.
Oh, no, yeah, and you've got that information there, but then and you can do some broad brush testing, but
Yeah.
until you have that last bit of planning or that last requirement nailing it down, which in Scrum may actually be your first day of your sprint planning, it may be for other Agile situations where it's only as the developer picks the item up that they finally clarify and fix down what they're building. However you look at it, at that point in time, until that point is done, I can only do broad brush test analysis.
Have you tried a BDD approach?
Yeah.
Well, that can tie into that, and that can be used. I've used BDD with varying success and previous play and that sort of things. Again, that then starts to tie into around the fact of how far in advance can you pin that down, and you start working through it. And in the good situation, you do have that case where you are saying, right, okay.
In a good situation, that is your story. That is what you're
Oh,
testing.
I completely agree on that there, and that is the ideal, from a testing point of view, that's the ideal situation. You get a degree of that analysis done.
Well, that's the correct order of things, surely. It's that the tester defines the right behaviour, then the developer's allowed to start.
Potentially, yeah.
From your BDD,
Yeah.
when
But-
you've said this is how that would
But then you've also got the side of things, a level of granularity. So if you're taking the situation, take a bit of functionality, and we're saying, okay, well, if, we're using given when, then, whatever it might be, when I do this, then this should happen, and that's the answer I want to get. However, there could be, we saw that on that boundary analysis, there's 6 values there, and that's literally for literally from 0 to 100. That's a really simple situation. And that's got 6. So we're going to have 6 BDD test cases. What happens if we've now adding on another factor in there, and all of a sudden we're now getting to 9, to 12, to more than that? How many of those cases are we going to write out at the beginning, or are we going to pick indicative ones to get you guys started? And then I start looking at that whole thing around, well, what happens if we're doing a beer ordering system and I put in goat? Or, well, we've got that 3, but there's only so many test cases you can put together ahead of time.
Sure, but I mean, as long as you've got your core happy path
Mm-hmm.
and a few of the fail paths, the sad paths, then you can start coding and you can be working
Oh, yeah.
collaboratively.
Oh, yeah.
Surely if there's a one-to-one with your tester and your developer, then
I would love to work in a situation where I only have one developer to work with. At the moment, there's 2 of us who are in our test team, and we have got 4 developers. That's the lowest ratio I've ever worked in. At one point, the worst of it, before the previous position, was if I finally badgered the manager into recruiting somebody else, there was me and 10 developers. So, yeah, I'd love to spend one-on-one. Yeah, and to be honest, it is not very common, use the right words there, for you to have a one-to-one tester to developer situation.
that sounds like an extremely efficient way to write
Yeah.
that code.
Well,
It's very practical,
yeah, it ties in and that sort of thing, and it does work. It does work well if you've got the good relationships going. I wouldn't personally want to have more than 3 or 4 developers per tester. That sort of number actually doesn't work too badly, because depending on the work items you're looking at, if you've got it cycling when you're working on it and your tester is working well with the developers, then I can be setting up the testing for what Paul's just developed and talking to you while the test cases are being set up for what you're going to finish off. I'll test his work while you're finishing your bit of development. If it's all fine, because I'm sure you'd never put any faults in your code.
You only test mine would be perfect.
But then once that's done, I can then, because I've spoken to you along the way, your piece is now finished, marvellous. I can start testing that. Someone else is picking up another piece of work, and you can start cycling it around. And if you've got the good planning at the front end, then you have got that chance. We can agree enough to work on, and you're working on it, whilst I then set up the more gnarly problems, the more difficult ones, the challenges to put against it. And the way I would normally work it is, you're building a bit of code, I'm sort of looking that over thinking, okay, and I'll look at it and suddenly go, we didn't think of that before. Just realised we've got a test case. Have we thought about?
Yeah.
And the number of times the developer's gone, oh, no.
Allow me to
Yeah.
do a day's work.
Yes, yeah, exactly on that. But again, earlier the better. If you've only got a day into it rather than 3 or 4 days into it, or you go, here, it's finished, and I go, yeah, I suddenly realised we didn't allow if they're trying to order a goat. And you go, well, why the hell didn't we? We just didn't think of it. But the sooner I can think of that option and say, watch out, don't allow strings in your number field, whatever it might be, the quicker we can pick those things up. The other reason, of course, for me doing things like this talk is to get you guys to be aware of some of these methodologies, because even better situation is if you know the sorts of typical negative attacks, I don't like that phrase because that's adversarial, but if you know the standard methods that I as a tester would use when I pick up your bit of work, then you can have a quick think about it. And I'm not asking you to take over the testing role, but you can think about it and probably clock some of the other obvious things, because one of the typical situations you get in mindset is developers tend to be happy path focused. Testers are anything but, and whilst you can never get to the point where you'll always think of all the unhappy paths, if you're aware of the most likely candidates, then that'll improve your testing up front, improve your unit tests and everything else, because you'll be thinking about, well, hang on a minute, when it gets to Antony, I know he's going to think about looking at stuff like this. Am I ready for him? Have I got it covered off? Lo and behold, when I pick it up and say, right, okay, I'm looking at these things, you can say, oh, by the way, I thought about if on that side of things, and I put that in there. You might want to double check it, but I've got some unit tests to cover that off already. And if you've got the good relationship, if you tell me you've got unit tests to cover it off, I'm not going to go and check them, because, quite bluntly, I can't read unit tests, I've got not a freaking clue. So I'm going to trust you and whatever dev review you've got, the Whitebox testing, to have covered that off. So, a note on automation. Often seen as the amazing cure-all, the panacea, the silver bullet, it will revolutionise testing. Yeah, they've been saying that for a bit. Partly because there's a difference between testing and checking. So computers don't test, computers check. Because checking is saying, if I add 1 plus 1 equals 2, well, the computer needs to know that it's going to add 1 and 1 together, and it has to know that the correct answer is 2. That's just checking that you got it right. If you say, okay, right, we've got a new feature on here, it's got a login feature. If you put in the username and password of a Patchett and password 1, you'll get in. That's the happy path. I'm not testing anything by doing that. I'm checking you've met the requirements that you really ought to have met already. And computers do checking. All they can do is what you tell them to test. We always say computers are dumb. So all an automated test can do is test what you've told it to test. Or check, I should say. A human actually tests it. They'll look at what's coming through, and the other great example I like to use, which is UI automation, is you're supposed to have a go button in the middle of the screen that is green and with a certain font. Now you could write 17 tests to prove that, but odds are your simple test will be, is there a go button that when you click it does the next screen? And that's what your computer will test. It will check that's there. The human will realise it's in the top right, it's purple, and it appears to be written in Yiddish. But the computer, as far as it's concerned, it knows there's a button it can press and it will take you to the next screen. Now, you can get more into that, but then that comes on to then, you still need test analysis. To create automated tests, you still need to understand what do you want to test? What are good tests for this feature? What is worth automating and what isn't? Because otherwise you have that situation where you sit there and you go, right, for this new feature, I've worked out what automation we want. We've got 87 automated tests we're going to create because I'm covering everything. Or you put the test analysis in and realise actually 3 automated tests will do it. That's more than enough. So you've still got to do that. Then you've got the question, who's going to create these tests? Is it going to be a developer? Are you going to have a test engineer? That's another resource requirement. It may either slow down the development of the work items or put more work on the test engineers or mixture of the two. Almost more importantly, who's going to maintain them? Every time a new feature comes out, somebody should be checking the automated test suite to double check that all the tests are still valid. Are you going to add any more? Are some need to have their values changed? Are some no longer relevant anymore? Have you still got an automated test to confirm that you have a login screen on a screen that you no longer log in on because it's automatic? You've got to look at that. And again, that's a resource. And what can often, so you can say?
What's your opinion of AI in this though? Do you think?
What a lovely idea that could do this. How does it know what to test?
Yeah, well, you have to think so.
Exactly. And to be honest, AI is another one, that's the latest big thing that I've heard about.
Yeah.
As yet, I've yet to find anyone who can show me a good machine learning AI system that can automate tests anywhere close to what a human can do. One day it might happen. Not saying it won't.
It learns how to test it now and then you change the feature.
Yeah. And then it's got to learn it again. And it's got to learn all these different things. And by the time it's done all of that, actually, how much money have you spent as opposed to having me in the corner going, yeah, but what if I put goat in? And yeah, it could one day become really useful. And I can imagine that for really big enterprises and so on and so forth, over time, it could become a better option. But we'll see, because they've been talking about, big noises about it for the last 4 years, and I've yet to see anything. It's possible there might be something out there if I sell my daughter and 3 kidneys that I might find something worth it, but as yet, no. But going back to that maintenance, lack of maintenance leads to lack of confidence, well, it leads to fragile tests, a fragile suite, less reliability, which then results in lack of confidence in the automated test suite. You have that situation where, and I think we were working together at the time, where you go, oh yeah, automated tests have failed again. All right. What? Well, they failed, haven't they? Well, yeah, we'll get back to that later. They always fail. Lo and behold, why bother with them anymore? Because if no one's maintaining them and no one's put the time in to maintain them, everyone expects there to be a couple of failures on the suite. Well, actually, actually this time, if we'd only realised that failure isn't a false failure, it's a genuine one now, but we can't tell because we're not maintaining it. And that's the other thing. So you've got to put that time in there. And if you get it right and you get it going well, then they're really, really useful, mostly for regression testing, because you're making sure everything else is still working. And at one point, where working previously, the regression suite for every release took me 2 days of manual testing through scripts. The only reason I still have a soul is because I only rent it out. It was truly soul-destroying. We put some automated tests in, got that going on that side of things, and we knocked it down to about half a day to a day, which is still a lot of time, but the nature of what we were building meant that you could only have so much in the way of automated tests. And that's the other thing that comes into it. Automation can't do everything. When you use it right, it is bloody brilliant. But it cannot be the panacea that some people like to claim it is. Simple as that. It's only a tool in the toolbox. However, something else that isn't a panacea, but I think is greatly underrated, is exploratory testing. And from an Agile point of view, exploratory testing is very much your friend. So before I start, anyone here actually know anything about exploratory testing? Heard it before? Yeah? Various people heard about the term of it. So first, simple...
Got some questions for my testers about it, but I think
yeah, I'll go through this and we'll see if they covered it off or not.
Yeah.
So first off, it is not ad hoc testing. It is not going, oh, there's a bit of software, I'll poke it with a stick and see what happens, which is what some people seem to think exploratory testing is. That ad hoc testing exists, and it is not much more than, I know, I'll do a few things and see what happens. Exploratory testing is actually a discipline. Now, one place you need to use it, and these aren't in perfect order, is there are some scenarios and combinations that are too complex for simple test cases. If you're writing out a nice little test script and you've got to step 83, it's probably a bit big. However, you can note down the situation, what happens in this area, and then rather than write a formal test script, you can then include that as part of your exploratory testing. Ad hoc, the problem with that is you're just kind of making a script up and you're not really writing down what you did, and is it really repeatable? Well, I don't know, I did this, this, and this. You sure you did? Yeah, well, I got this fault. Okay, you've got to find out why. Exploratory testing has a bit more discipline to it. But it does also, one of the other key things useful about it is, as you may already know, bugs are social animals. They like to spend time together. It's the fun way of putting it, but it is also true. Where it's one of the little truisms in testing and software development, as you may already know, is that when you find a fault, there's a higher probability of you finding more faults in the related area to that than other places. Because usually that fault is an indication of complexity. Now, sometimes it's a really stupid, blatant thing. You just go, no, the reason the fault is there is because somebody was hungover when they coded that. But otherwise, if you find a fault, it is probably an indicator of complexity. And the more complexity there is, the more chances there are of there being gaps in our thought process when we built it. So, one of the benefits of exploratory testing is because you don't follow a specific script you've written out beforehand, if you find something, you are free to explore that area more. But it does require discipline. It's not just sitting there and cheerfully plinking away at the computer and saying at the end of it, oh, I did a load of testing. And I'll talk more about some of the disciplines, some of the methods involved in how you make sure you do that. But it is very flexible because you're not following a set script. The whole principle of exploratory testing is you work out your script as you go along. And I'll talk a bit more about this. And again, the other useful thing after all that talk of time so forth, it doesn't require detailed advanced analysis. because you're actually doing your analysis as you work. And you also get quite a lot wider coverage because you don't have to worry about making sure that you've got a test case for everything. You can have maybe a few formal test cases if that's the way you work for some key areas to make sure you've ticked off the big items on the requirements list. But exploratory testing allows you to go all over the place, the crevices, around the place, wherever you want to go. And by the end of it, because of all the reporting you've got in it, you can turn around and say, I've covered a lot more ground because I've found areas I didn't even think needed a test case to cover this off. So, how to do it right. First thing is, there is a degree of initial analysis. You can't, I say, you've got to have a little bit of a think about what am I testing, what are the possible areas I need to look at, how am I going about this. Then what method are you going to choose? And I'll talk about this a bit more, but are you going to use some heuristics or the tourist approach, which I love, and I'll talk about in a bit, which is basically how are you going to approach your testing. You then have a charter, which I'll talk a bit more about. Fingers crossed I've got time, I've lost track of it. Another key thing is it's got to be time bounded. You always put a time scale on it, partly because there's only so much brain time you've got available, but also because it's part of that discipline. You don't want to get lost meandering down one path or another, and at the end of it go, well, I don't know how much use I got out of that. If you've got it time bounded, you can then know you're setting in a lot more specific sessions rather than you're spending the whole afternoon bimbling around the place. You've got your reporting, which the charter provides for, which then means we can turn around and say to the rest of you, no, I have tested these areas, this is what I found. You might have some follow-up testing in there, and the other key thing is, when you look at the methods, is always to use a combination of methods. That way you're going to get a far better chance of covering off the areas under test. So, heuristics. These are some of the approaches you can use, so things like claims testing, where, okay, this is what we say this bit of software is going to do, this feature is going to do. Right, fine, I'm going to focus on the things that you say it's going to be able to do, and I'm going to use that as the starting point for me exploring my exploratory testing. Risk testing, another good one which lends itself very well is the actual user journey scenario testing. So we've got a little feature here we just added. That's nice. We'll test that. But users don't use that in isolation. So one good option, without having to write a script beforehand, because that way you always vary it a little bit, is you follow the user journey that will include that feature. And the way that works, that sort of things, I'm going to skip a little bit of this in terms of other approaches on here to make sure I explain this. The way you do exploratory testing is you have an area you want to look at, and you start it off and say, right, I'm going to start looking at this. I put this, you log down, I put this input in, I've done this, so this is the results I got. And as you go, you look at things and go, well, I'm not really finding anything here. This is very, very vanilla, Jack and Jill. Oh, there's a lot of interesting complexity in that area there. There's a whole set of submenus on that. Oh, I didn't realise you got that in there. And you will explore that particular area of the area under test until you feel happy with that bit. And then that might lead you to somewhere else, it might not. But rather than saying, I will do this, then this, then this, you go in and as you're going, you're saying, oh, there's something interesting there. I'll look at that a bit more. This actually, no, there's nothing particularly interesting here. I'll skip over this and go there instead. All within that discipline of I'm testing this particular area under this approach. The tourist approach, however, I'm going to talk about, this is one of those ways of, and I don't know if you guys have seen this before, heard of this before or not. How do you go about choosing where you're going to test? If you put stuff there. So, first one is, if you imagine it, you're visiting a new city you've never been to before. How do tourists approach this? Well, one approach is, I've got my guidebook. I'm going to go through this and it says I should visit this, and then I should go see this. I really ought to eat at these restaurants. Software terms, that's a user manual. It's a user manual, it's a user spec. It's whatever we are telling the users, this is how you're going to use this bit of software. That's the equivalent of a guidebook. You've got the bucket list. This is the big, you go to Paris. Where are you going to visit? Well, I'm going to do the Eiffel Tower, I'm going to do the Louvre, I'm going to do Notre Dame and so forth. In software terms, what are the big ticket items? What are the items of this feature or this sprint or this release that we've sold to management, to the customers, whatever it might be, are the really big shiny things that we're going to, this is all new, all singing, all dancing, this is great. Well, one approach to exploratory testing is to make sure you hit every one of them, possibly in a session on their own, and you focus on the big shiny stuff. Because not only is that obviously something we want to make sure we get right, but again, it's an area where you may find all sorts of stuff going on because it is such a big ticket item. You don't have to, it's one of the approaches. Then you've got the quarters. So you might visit someone and say, oh, where are we going to go? We're going to go Chinatown. We're going to visit the Merchants Quarter, whatever it might be. In this approach, this would be, you choose a section of the functionality and say, right, for the next 2 hours, whatever it might be, I'm going to lurk and rummage and wander around as if you're wandering up and down the back streets or wherever it might be of this bit of the software. And then finally, we've got the red light district. Now, not many bits of software have got that sort of red light district. However, it is the kind of the code word for not only for the dodgy part, but generally the grimier parts. You know, is it the off the beaten track souk where you're going to find some interesting things so long as you keep hold of your wallet? Is it going to be the old quarter, and that's the quarter something, but all the various areas that are very much off the beaten path and you need to know about, and you might get robbed, you might find the treasure of the century, who knows what's going to happen. Exactly, here they be dragons. In software terms, these are the gnarly bits. These are the places you found faults before, that you know the developer was banging his head off the desk trying to build, whatever it might be. These are the bits where you know are the most likely areas that we're least comfortable with the strength of the functionality. They exist in every bit of software. They're always there. So you focus on them. You dive into those grim and grotsome parts in there because that's another good area to find stuff. And sometimes that comes down from experience and being testing the same area for long enough. You know that there's certain bits of the functionality, whether it be because the way they chain together or whatever's going on, that are the grotty areas to have to deal with because they're always going to have problems in them. You know, there's some legacy code in there, there's that bit we've been meaning, there's some technical debt that's been meaning to refactor that for ages. That's a really good place to look for some crap. And that's what you focus on. So, the charter for exploratory testing. You cover off, first of all, what's the aim? You've got to have a purpose to it. 3 minutes. Right. You look at the areas you've got to cover off, and you want to make sure you look at this. Where am I looking? What environments? What am I actually focusing on? Who's doing it? The timings, both how long we're planning to do it for and how long did I do it for? Because that's part of your reporting. Did I spend the afternoon pressing the enter button 50,000 times? No. This is how I actually spent my time. Your notes, that's actually what I did. That's that script as you write it as you go along. I did this, I saw this, and this is what I did next, and so on. You have your faults, and then that sort of things. What did you find? What are the steps to reproduce? And finally, what follow-up testing? I didn't go into that. I realised that looked really interesting, but it's not in the scope of this session. So I've noted it down. I'll pick it up next time. And look at that. On there. So yeah, that is a very brief of other things, and I'm happy to talk to people at a later date or online, whatever it might be, about exploratory testing, because it is a passion of mine. It is a very useful technique.
What do you mean when you say fault? I mean, it's just
like,
window.
yeah,
It's like a client who didn't want to pay for bug fixes, so she called them fault.
Fault versus bug. The way I look at it is I do something and something unexpected happens. In that first instance, it is a potential fault. That doesn't mean it's a bug in the code. It could be it's an environmental issue. The fact is our testing environment is never going to work right on that because there isn't enough memory in place for us to do those functions. Nothing's wrong with what you've written. It could be, as we call it, a picnic, problem in share, not in computer. I've put in the wrong data. It could be any number of these things. So initially, it's a potential fault. It also could come down to the fact we've done it perfectly fine, but against the spec it's wrong. So actually, do we need to change the spec, or do we need to change what we've done to meet the spec? Okay. At the end of it all, if all that's what else is written off, then it's a bug in the code. And that's why I tend to call fault versus bugs.
Okay. I've just got a quick one.
Yep.
You've answered actually all the other questions, so that's really good. In our team, we don't have experience of Whitebox testing, we only do Blackbox testing.
Yep.
And this is from, I think I know where he's coming from. What is your recommendation to be able to quickly and easily incorporate Whitebox testing into our Agile team?
Talk to your devs.
Yeah.
To be perfectly honest, I don't think dedicated testers should do a great deal of Whitebox testing.
As a developer.
Unless that is if it's an engineering test or a test engineer or something similar, then possibly. Right. But at the end of the day, if you're spending all your time rummaging through the unit tests, who the hell's doing the rest of the testing? You'd like to think that your developers would cover off that side of things, dev reviews, walkthroughs, unit tests.
Yeah, we do
That's
peer-to-peer reviews, and we use Team Foundation Server and all that kind of stuff.
Yeah.
Okay.
Right, I'll go left to right, just cause.
For your non-exploratory testing, what's a good system for using Agile for recording test cases and scripts?
Well, to be honest, apart from not using Microsoft Test Manager, because I hate that with a passion that's almost holy, it depends what else you use. I mean, we use Jira in the office, and there's about 7 or 8 different plugins. There's Test Manager, there's Zephyr, and to be perfectly honest, they're basically all different flavours of the same thing.
So plugins, Jira, Music
Yeah.
my ears because we use Jira too.
Yeah. There's several good ones. To be honest, having looked at them, mostly they vary because some of them are test managed and some of them manage tests. There is very little difference. Try them out, see which one works better for you, see which one works.
I think so at the beginning you said that, well, obviously Agile kind of conflicts a little bit because you're not really working on a particular story. So have you found any like processes in place where you like allocate a set amount of time per sprint to do a bit of this kind of stuff, or do you ad hoc? Have you found a process to kind of fit that into Agile?
What we've tended to do, I mean, at the moment I'm not working in Sprint, but when I was, the simple approach was when it came to story pointing, then if I thought something's going to need a heck of a lot more time to test it, I insist on points being added onto it. At the end of the day, if you're looking at a Scrum team, your testers are part of your Scrum team. They're part of the resource. Anyone who tries to separate that has missed the point. You're part of the resource, which means if I'm going to have to devote 2 days out of the sprint to putting that much effort into getting that really nasty piece sorted, because we know it's going to be horrible, it's going to head into that red light district.
That's exploratory then, is it though? Because you're
Well, no.
basing it on a particular story.
Well, that's the point, is the exploratory testing isn't just going, I'm going to spend 2 days of this sprint cheerfully poking around what's in there. You do that analysis in the first place to say, we are going to add in these 3 new features and this bug fix, whatever it is in this sprint. Well, in which case, part of what I'm going to be doing is some exploratory testing time, but sometimes there's no point. What is this story? This story here, it's only a 1 pointer. What are we doing? We're changing the button from blue to green. Okay, well, I'm not really going to spend a lot of time on exploratory testing on that. On the other hand, something else might need it, so it's effort, which means it goes in the points.
So you'd expect, because obviously all Agile teams have their testers,
Yeah.
so you just expect the testers to kind of give a bit of padding to allow that time.
In effect, on that side of things, yeah, because I wouldn't really say it's padding as such, it is team effort. Because at the end of the day, actually, if you've got the classic T-shaped skills, well, in fact, if I'm utterly snowed under, if I've worked out the test analysis, I should be able to give some of that work over to one of the devs to help pick up. Because if you're working through test cases, you're working through test cases. So long as it isn't the dev who built it, then someone else can pick it up. And that's only because the dev who built it will know too well about what they expect to happen. If you've got the analysis done, then someone else can pick it up. So it's team effort. And it's not about the tester is an integral part of the team. There is no 2 sub-teams involved.
We used to put a little subtask underneath like testing with its own estimate on it, so it was literally a first class citizen in the sprint.
That's another way of doing it.
It's not padding, it's
Yeah,
It is its own thing.
yeah, it's
And it also reminds you it needs to be done as well.
yeah, exactly.
all I was going to answer, have you worked in a team or with any company who has used mutation testing at all?
Not particularly, no, on that.
It's so rare. I've yet to find somebody I can have a chat with about
Yeah.
whether it's actually worth bothering.
What I will do, however, is and to be honest, that said, however, I will spend a bit more time looking at it, so we can not just so we can chat. It's because I'm always looking for new and cunning ways to find the faults. Well, no, it's to find the faults before the users do.
Yeah.
And that's one of the things that you do find is some testers are very adversarial. I'm not. I actually half the time I apologise to the devs when I find something, because I'm really sorry I found this problem, because they put you put your heart and soul into it.
Yeah.
Nobody turns up and goes, made some code, and if they do, you don't want them. So yeah, I'm sorry I found a problem in your code. I really wish I didn't. My ideal life is I spend all my time doing pointless work, because that means that you've built code that has no faults, that makes our customers happy. So,
Yeah, just a point. What we try and do to mitigate the issues with the short time frame for testing within the sprints is actually to let the testers look at the whole release, because we do like 4 releases a year.
yeah,
It might be a case that we particularly have, but we actually find that works really quite well. So they kind of have a broader scope, and then actually based on some of their advice and their recommendations, we can actually alter what comes into the next sprint based not only on development but also on testing.
Yeah.
The testing time actually is a huge part of the whole release. The accountants are always complaining about how much it costs.
Yeah.
So we actually try and do that, and it just helps us mitigate that very short, sharp shock of things going wrong in one sprint.
No, that does make sense. And the other side to it is, just quickly mentioned, there's a difference between testing and QA. And this is one of the things I see a lot of people say, oh yeah, no, QA, you're the QA. No, I don't do QA, because QA is quality assurance, which means I have to have the power to assure the quality. Now, unless I can dictate, therefore, which training courses devs go on, I can turn around and say, no, this is the level of coding standards we require, and so on and so forth, I can't assure quality. What I can do is assist with quality by speaking to devs up front about things to look for, things to watch out for, what I would be looking at, and therefore cover that off. But QA is a very different function, and it isn't testing. That said, in situations like you've got, there is an element of that assisting with quality up front you can do. Yeah.
It's very valuable,
Yeah, the danger, of course, is if you've got to make sure you're still doing your ongoing testing throughout that release, otherwise you end up in mini waterfall.
Yeah.
But no, if you're doing that, that is another way of doing it.
Can we leave it there?
I'm quite happy to. These people keep asking questions, it's not my fault.
Eagle.
Thank you very much.
Oh, thank you.